Cool. All right, now that it's 10 o'clock, I think we'll try and kick things off. Class seems a little light today, but I'm assuming everyone's gotten whatever is going around the city this past week. Um, so today's class is going to be a little bit of a reiteration of what we've already seen. We're going to talk more about ORMs. We're going to talk a very little bit about MVC, is an architectural pattern. And then we're going to finally introduce Sequelize to the whole mix. So before we kind of get right into things, you guys probably noticed there's a new person in class in that corner. It's my girlfriend. She doesn't believe that I know anything, so I brought her to class to show that I do know something. But besides that, let's kick right into it. So MVC. What does MVC mean? The M in the acronym means model. The V stands for view, and the controller, and the C stands for controller. You can think of this as just a way of breaking out the logic that we saw last time in class. You know how I drew a pattern on how everything kind of communicates with each other between the template, between the node server, and then the database. You can almost think of MVC just like that. So when you break it up in a very high level explanation, you could say that the M, which stands for model, also handles a lot of the database interactions. The V, which stands for view, handles the template interactions. That would be all your user interactions, the events, the layout of your website, things like that. C, which is the controller, also you could say is the back-end server layer. So you could say that would be the server interactions, which would be your Node.js logic. And your database would be like your ORM. It's important to understand this acronym just because it does come up in interviews, and it's also, I don't know, it's a nice way of logically separating these individual parts when you're talking about them. So when you're having a conversation with another developer and you're saying, well, I think the issue it can be found in the view, he immediately knows that you're not talking about the database layer. You're not talking about the Node.js layer. You're talking about the templates. That would be the HTML, the CSS, the front end JavaScript, things like that. So folder structure wise, you might also potentially find this convention in code bases. So I really wish I could zoom in to this corner, but in exercise 16, you'll find the folders broken up exactly the way the acronyms are. So you would have the config layer, which defines your database configurations. You have your controller layer. You have your models layer. Then you have your views. We'll start with the simplest one, which would be the views, which is the template interactions, HTML, CSS, and all of that. You would find your partials, your index, your handlebars, your index handlebars, your main layouts. That's where you would find all of this information. Then, after the views, let's dive into the controllers. Controllers would be where you're defining your different routes. This would be kind of like, this is your main, I guess, the core of the logic in your website. This is what you would put inside your controllers. This is how a user presses a button from the front end, and that event triggers some logic on the back end. And that logic is what you define in the controller. So we're saying for the index page, we're going to grab all the information from this cat object, which is our model, and this all you can think of as a helper function. This helper function is a English readable name that tells you I'm going to get all of the cat objects from my database. Once we get all those cat objects, we're going to console log it out, and then we're going to render the index page. Same thing with this next router, this post function to API cats. We're saying if a user has some type of interaction that's a post request to this endpoint, then we're going to create a brand new cat, name it Sleepy, pull the parameters and arguments that I need from the request, and then return back a JSON body, and so on and so forth. And those are the type of things that you'll see in the controller layer. Things that we've already done before is just being extracted out into its own logical layer in a different folder. Then we have the models. And a model is the database interactions. This is going to be your ORM. This is going to be your SQL query statements. But once again, we're just refactoring the logic into individual places. So right now you'll see in this CATS model, it has a require on the ORM, and it is using the ORM to execute SQL statements. From the controller looks at the model like a black box. It doesn't understand the actual SQL statements being created on the back end. All it knows is that as far as the model is concerned, the controller has access to all, the controller has access to create, and the controller has access to update. And these pertain to a cat object. So we can assume from a controller's point of view that we're able to get all cat objects, we're able to create a cat object, and we're able to update a cat object. That's the whole concept of this whole pattern. Just abstracting a logic into their individual places. So for the all function, the ORM also happens to have an all function, and that passes in a cats parameter, and then the result is then executed inside this function. So we'll get to that in a second. But let's dive into the ORM and see what exactly is going on. So when we take a look at the ORM, for the very first one, which is going to be all, just a select statement. And as you can see, that the first argument it passes in would be the table name. So select everything from table name. Once you get everything, execute this function on the result. Same thing with create. Create is going to take a table name. It's going to take in the column and the values of those columns that is going to create this new database entry for. Once it executes that create statement, the insert statement is going to execute a callback function at the very end. Questions on just the ORM? I know we've only just started learning about ORMs, and we did a lot of exercises on it, but I want to see if there's any lingering questions on what the concept is behind that they're just helper functions for the database so that you can reuse these SQL statements over and over again in your code base. So, was that a question back there? No? Okay. Cool. So, now let's take a look at what this callback function is that's being called. So from the cats controller, we are calling the all function, and as you can see, we're passing in this function over here into the all function. When we dive into the all function, you see that its only parameter is a callback. The ORM has two arguments, which is the table name and a function, but the cat all function only takes a callback. Our rationale for that is that the less things the controller knows, the better. We're abstracting away logic. So all the controller needs to know is that I'm going to use this cat object, I'm going to execute this all function, and I'm going to pass in a callback so that when I finally get that data, the data from the database, within this scope, I have access to it. Remember how we were talking about async JavaScript before and the thread time to lives? So the first thread is going to execute cat all function, and that first thread is going to die immediately. This data, this logic is going to be ongoing in the background, and when it finally returns with its own information, it's going to have this scope of work to be able to work with that data. So it's going to get the result from the database, it's going to insert it into this HBS object over here, console log it out, and then render the index page with that cat object. Questions on just that callback logic, because you're going to see this over and over again as we get deeper into node development. Yep. Yes. We're passing a callback function in as an argument so that we can still reuse that data that gets returned from the database. Because it's an asynchronous call to our database. It's not a blocking call. So your code is going to continue executing, and there's going to be this new worker thread going to the database, returning information, and then it now has its own time to live on what you can do with that data. Sure. Yeah, any other questions? I'm going to give you guys 5 minutes to, well, 10 minutes to pull down this example, exercise 16. I want you to, where is the, let me try and find the SQL statements for this. There we go. Yeah. So for 16, create your database, your CatsDB, create your seed information. And I want you to be able to run this server, and I'll run it real quick just so that we can see what it's supposed to look like. I'm in the right place. Yes. Exercise 16. So this is what it's going to look like. Cats that are not sleepy. And you're just going to see the names of the cats that you've created that are not sleepy. You are going to see the names of cats that are sleepy. And they have a sleep time. They have a delete button. And then you can, when you click the sleep time, they move down to this section. You can wake them up. They come back up here. That's just what the front end does. But I don't want you guys to focus on the actual logic of this application. I want you to focus on trying to understand how these interactions work between the model, the view, and the controller. So let's take like 5 minutes, or yeah, 5 minutes setting this all up, and then ask me any questions, because this is going to tie directly into the next exercise. Yeah, it looks like somebody took a let me try to find it. I appreciate that. Okay, we've got 2. Which rows need? I need one row back there. Just a way of breaking out that math. And do you guys think you can find value in redrawing that map again? The interaction. Okay. Yeah.
Oh, I can move down.
Thank you for trying.
All right. Everything is missing from this class.
It might be as simple as just managing making tweaks to it based on the so, but if it was true, then yes, that would be I'm worried.
Okay.
I'll be a corner.
All right. So I hope everyone was able to, one, create this database, two, see the cats in the database, and begin to walk through the logic inside this code base. If you were actually taking a look at it, then you would have noticed that there's something new inside of the views. When you take a look at the views, we see our typical handlebars syntax, which is the each, which we can assume this is an array, and it's going to iterate through each cat, and it's going to print out some type of information. What's new over here are these unless and if tags. I'm going to send you a resource for that. We're going to Google handlebars if. See whenever that wants to load. All right, there we go. Blah 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 blah. Yeah, let's look at the handlebars if statements. Nope. All right. Well, I'll look for that later. But this is what it typically looks like. And an if statement acts exactly the way we've currently been using ifs. It's checking to see, is there an attribute inside of this cat's object called sleepy? Is it true? Is it a Boolean value? So if sleepy is true, then it's going to print this out. Unless does the exact opposite. It's if sleepy is false, then it prints out this information. So it does just the opposite of what an if statement does. Nothing too crazy over there, but I wanted to be aware that you guys can see how you would handle those different interactions. So this handles the false case, unless, and the if statement handles the true case. And we know sleepy is a Boolean value because we just created that cat's database. And when we take a look at the content inside of there, you'll see that 0 stands for false and 1 stands for true. Cool. So, what was I about to do? I just wanted to redraw the request lifecycle just to cement the point home and also include the MVC aspect. So we have a template. Should be handlebars and our HTML and our CSS. And our user, this would be the user, interacts with the template. This is our view. This is just the life cycle of a request. The template then interacts with our JavaScript. And technically, you could also think as the front-end JavaScript as part of the controllers. Because it is handling logic, and sometimes it handles a lot of logic. So this whole section over here, when the JavaScript now interacts with our node server, so you think of all of that as the controller, so to speak. Now, inside of our node server, we're defining a model. And the models is our middleman between our interactions with our database. That's going to handle all the ORM functions. It's going to handle our database schema, definition, all of that. So you could say within the node server, we have our ORM, and this is our model. And that handles all the interactions with our database, which right now we're only using MySQL. The lifecycle of a request is our template is going to interact back and forth with our JavaScript. That's going to execute a request. Call this a request to our node server. It's going to provide a response to our JavaScript, and that will cause some type of interaction on the template. Our node server is going to use our ORM, which is going to execute SQL statements to our database. That's going to provide a response. That response comes back to our node server, and it goes all the way back and initiates change on our template. But this is how they're logically broken out. Model as an ORM, controller as the front-end JavaScript and the node server working in tangent to tie these interaction points together. Just another way of explaining what exactly is going on in your website. So, any questions on like the life cycle of a request and how they're broken up?
So I know MVC is very popular with a lot of languages, but
yes,
it's not the only way to do things, right?
It's not the only way to do things. It's just it's a nice convention that kind of provides some sanity to I guess providing structure to your code base. You can when I see a models folder, immediately I understand there's going to be a lot of database interactions. If I see a views folder, I know that's where I'm going to find the templates. Controller will handle the logic that ties those two together. It's just a nice way to make sure that every developer has a base understanding of how things are broken up. Yeah. But as you guys are writing more and more code, you're realizing that all of your logic can't just fit in one long JavaScript page. You're gonna have to break it up, and this is just a logical way of breaking it up. Questions? All right. So let's actually take a look at exercise 17 and see what they want us to do. So when you take a look at exercise 17, you'll notice, oh wow, it's the exact same thing we just saw in exercise 16. The only difference with this one is that we're going to build out that functionality. So let me slack out these instructions. We're going to spend 20 minutes here. When you load that up, of course, the unsolved will not have this delete functionality, but it should have the sleep time and the wake up time functionality. And then you'll also be able to add a cat. So let's do this for the next 10 minutes and just I want to get you guys comfortable in playing around with code that's refactored out into separate places, because you need to get used to being able to, one, navigate a code base quickly and provide functionality quickly. So yeah, so I'll walk around and let me know if you have any more questions. All right, 20 minutes, that'll be 10:45. Cool. Any questions on what we're working on right now? Just the delete functionality that we're looking to do. Adding some more details to the ORM, tying that into the model, executing it with the controller, showing it on the view. Yeah, I haven't seen you. So let's start. Are you familiar with SQL statements? So we have a SQL statements.
That's
That's a pretty nice setup. Uh, 10 more minutes and then we'll move on to the next exercise. Yeah, sure.
No.
Oh yeah, that's just because they forgot to update this exercise to have non-vulnerability affected libraries, so you can just ignore that. Yes.
I'm having a problem connecting to my local.
Really?
It says I'm connected,
Okay.
and then I go to local.
Let's look at your server again. The terminal. It's the 880. Okay. It's 880. And you've already created a database, right? The Cats TV.
Are we using the same database that we created for?
Yes, it's the same one.
Yeah, I have it already.
Okay.
So I've already checked that this actually 16 months.
Yep. Oh, that's strange. I've got a question. Are these two tied together? Like, are you running a server up here that might be blocking a server down here? Okay.
This is a different local.
Oh, okay, okay.
3,000 anyway.
Got it. Yeah, I'm not sure what's going on. Let's cancel it. Let's Control C that server. Yeah. Oh, something happened. Let's go back to the browser. Okay, good. No. Maybe it just took a while. Let's click sleep. Let's see if it works. Alright, yeah, it's working. You're good to go. I'm not sure why it took forever.
Alright. What?
I know that, but I don't know. There's a release. Alright, cool. I'll work it out. Quickly with that list. As long as you get this little thing up here, so just like you figure out how to make it work on the center stuff. I was ready to go around. Looking at there or I did distracted one level above where it doesn't really know anything about the other line of the base because they're going to get the cable value that it is. But not the cable value. So for me, my all around, all those are just yeah, so I don't really know. Still don't understand. Yeah. And I think in our
Yeah.
but yeah.
So otherwise, really, right now,
Strong.
It's just, there's no value yet that I see. Why haven't I?
So don't we basically have to add one function, each one they specify here, and they set it as delete instead of like whatever they have, like update, insert into, which is the create. So we have to do it in text.js and ORM.js as well as the text controller.js. Yeah, I don't have a perfect idea, but that's where I'm starting at. See, that's what the instructor is. Sorry. It's part of the
This just reuses the form. Yeah, let's call it so it's not really.
I knew that was
It's called. It's just an extra step.
Okay, so let's move on. I just want to walk through the solution for this, just real briefly. Just a reminder, you didn't have the delete button before. So you have all this other functionality, which would be adding cats, temp, cat isn't awake, and then being able to wake up that cat, it moves to a new section, changing the flags on the cat, they move to other sections. Those are all just create and update statements on the back end. And what happens as soon as you trigger a button is going to reload the page, pull all that information from the database, and then break them out into their individual pieces based on those if and unless tags that you saw in the front. So if unless they're sleepy, then they end up over here. If they are sleepy, they're over here, and that's based on the zeros and ones from the database. Just a reminder, a 0 accounts for false and a 1 would account for true. So let's take a look at the solution real quick. If you look at the model, you have to create the delete function. And that delete function then calls another delete function from the ORM. Now let's take a look at the ORM. Inside the ORM, we should have a delete function right here. And what that does is it creates a query string, delete from. You need a table to define where you want to delete items from, where, and then the condition. And this condition would be probably where cat ID is equal to XYZ. So when it executes that condition, it makes a call to the database and then just returns the results to the front. So when cat executes delete, is going to pass in the table name, which is cats. It's also going to pass in the condition. That condition, it looks like, is being passed from the controller. So when we go to the controller, cats controller, we should see a delete router being created. So router.delete for this API /cats URL /ID. So it's safe to assume that the condition is based on the ID. So wherever the cat ID is equal to the request parameter ID, the one being passed from the front end, then it'll delete that specific cat. Once it gets deleted, it's just going to return a successful request to the front end. Now, let's take a look at how the JavaScript handles that from the front end. The JavaScript is going to execute an AJAX call to this URL. This URL is going to delete that object from the database, and then it's going to return everything when successful, just a 200 request. Reminder, this is not a render request. This is just a 200 request. Rendering would reload the page, would load a brand new template. So that's what we saw over here in our get function. When we first load the page, it's a response render, and that would render the index template that we see over here in our views. But that's not what we're doing for delete. So let's see how we're handling delete. If we go to the public folder, assets, JavaScript, cat.js, there should be something that references deletes. Here we go. Delete cat. Let's find out what that is. As we can see, it's a dot notation, so this is going to apply to all items that have the delete cat class. So when we take a look at the index, I think it's in the index. Let's look for that class. It's not there. Let's look in the partials. Cat block. Is that where it is? Yeah, there we go. Delete cat. So this is going to pertain to the buttons for each cat. And let me load that server up. If I go to solved, node server, I refresh the page. Oops. It would be these buttons over here. These individual buttons that get created for the cat have the class delete cat and the data ID that pertains to the cat object on the back end. That's how these are all being tied together. These IDs are tying the front end all the way through to the back end. So when we click the delete button, that JavaScript gets executed. Where is it? Cat.js. Is this it? No, that's not it. Let's find out where it is again. I lost it. Boom, here we go. This delete block gets executed on click. It grabs the ID from that front end element and it makes that call to the API cats, passing the ID. And then once the cat is deleted, it console logs it out and then it reloads the page. And as we saw earlier, reloading the page will execute that route, the get route in the controller. It'll hit this, grab all the cats from the database again, including the fact that the cat has been deleted. So you'll no longer see that on the front end, and it'll render the index template. There's a lot of talking to explain this entire request flow, but once you practice and continue to develop in this space, it'll begin to make sense, and it'll begin to look a lot less convoluted and a lot more seamless. So the next activity that we're going to work on before we talk about Sequelize is just going to be a reiteration of this once again. So let's go to the exercises in activities or number 15. Let's Let's figure out what that's called. If y'all go to class content 15 for the sequelize exercises, yeah, the very first exercise in there would be number 1, chirpy MySQL. Let's open that up. Yeah, week 15, that's what I mean. We'll cover up to 5. Yeah, first activity in week 15. I'll give you guys a second to get there. Yeah, week 15, exercise 1. Okay. Has everyone navigated to week 15 and you're ready to start working on exercise 1?
How many, which one's going on again?
Week 15, exercise 1.
No,
Oh, we're just going to go through, I think, up to the 5th one, the 5th exercise. So yeah, let's take a look at what that is. So let me start this server. So we're going to be working on this activity called Chirpy. You want to think of this as a very basic Twitter. We're going to create a handle. Let's call him Bob. And then he's going to tweet chirp hello. And then click submit. And then at the bottom, is going to grab that chirp submission and then just print it out. So it's grabbing all the chirps from the database and loading them on the page using handlebars. Things we've seen before. So what are the things we can expect on the database? Just looking at the front end, one, we're going to need a column that's probably going to be called name or whatever, something that relates to a name, and then something that relates to the post body or the chirp, so to speak. So there's going to be 2 elements, 2 string elements, one for John, one for like a name, and then you're also going to have the actual message. So when I hit submit, on this on-click event, this is going to be an insert command. It's going to insert a brand new chirp, and then it's going to reload the page. And when the page gets reloaded, it gets all the chirps from the back end and just prints them out. Let's take a look at the database. You guys are going to get some boilerplate SQL stuff, which is going to create a chirps table. And inside the chirps table, you're going to have an author and a body. The author and the body directly tied to the name and the chirp. So when I refresh this, it should have the new ones that I created. Let me refresh. There we go. And you'll see that these correlate directly with the chirp speed that you see in the screen. Steve said message. You can see the message is a body, and the author is Steve. What we're going to do is pretty much, I believe the boilerplate doesn't have all of the creation stuff. Let's take a look at that. Don't save. Let's open up a new one. Let's look at what's being provided to you. So when I look at unsolved, you're going to have your basic server definition, and inside your app, you're going to have routes, but you'll have none of the routes. So you're building all of this from scratch. And we are going to be working on this for the next 20 minutes. So feel free to grab boilerplate from past exercises. Do whatever you have to do for speed, because there's a few moving pieces to this. We need the select everything from the database function. We need to create this new chirp function. You don't actually need to delete anything, and you don't need to update anything. So it's just those 2. And this is just a reaffirmation of like creating MySQL SQL scripts and tying that whole interaction together. So we'll be building out the API routes. You guys have all of the templates available to you, and you'll need to define an ORM to help you execute these different functionalities. So let me slack out these instructions. All right. The point of this exercise is, one, to reaffirm that we're writing things the hard way, raw SQL scripts, and executing them on that database. And then we'll introduce SQLize and show you how we can do this a lot quicker.
What's the app skeleton that's provided?
The app skeleton. That's the entire unsolved portion.
What we have
Yes.
inside that folder?
Inside the app folder.
That's like nothing.
Yeah, pretty much. You need to build everything else. That's not enough.
Just take this.
Oh, because probably didn't search for C information. You look at your we need to make that call. So that you actually can hit this and get this right. So now if you look at the so inside of the house, we need to get it that's going to so it's just like you said. This is so I'll show you. Same. There we go. This insert segment into the trace. Apply. There was an arrow. There's arrow. Create created as so yeah, it'd probably be easier for you just to do it live and create that time and do it back. So we'll ignore but yeah, but you see how that ties together, right? So this is like a call, get everything in the front end, that's going to combine back here. So try to take small pieces from the solve and move them into unsolved and see how that goes. Sure. Okay.
Select is to select the database.
Save it. Then save the file. Yes, you do.
ask something? Semicolon slash quotation mark. I'm telling you, man, it's artificial intelligence becomes a thing. Well, look on the bright side. A lot of things that we're humans make mistakes. Really. So there would be any. No. So imagine every car was self-driving. The fuck up isn't the car. It's like the drivers from humans. So the only way it should work is if you ban all human-driven cars. They all get banned and they all go to like in New Zealand for that massacre that happened. The next couple of days, what happened? They banned all software. You think we could have doing it? We have more people doing it. And most people we have what, one every 3 days in there. We still do shit. We don't have universal batteries. 97% of people put you in your phone. I would keep some. If I have someone, if I have like, that's just like, basically that's cool with like, it's cool with the thing is, it's malicious, it's yeah. Well, the thing is, policy, whatever policy, either saves people's lives or kills them. So right now we're using policies that save people's lives. It's going to happen again. I don't know. So there's dead people literally walking. Huh? Yeah, all right. There's no there, we had, and we had remember that one in Pennsylvania where like 40 kids died? That didn't do shit. We had the Los Vegas guy with a sniper rifle killing people that have come through, festival. 50 people dead. No, 50 people dead, 200 injured. Huh. Who cares? We had Columbine, of course. A whole bunch of other ones that like, because they're being paid by the NRA. The NRA gave Trump $7 million. And a lot of the Russia thing, like, the NRA gets so much money. The NRA is a terrorist organization. They attempted to put me on the terrorist watch list. Went through some flying planes. They wanted those people on the terrorist watch list. You're on the terrorist watch list. You can't fly an airplane. There'll be a lot more out there. Fly in an airplane, but you can buy it. That was a terrorist. They have only one incentive to make it. It's not even about this. All rights have limitations. You can't go and say there and say fine. So go fine. You're okay. All of the limitations there. So the problem is even common sense stuff like the federal level that they have 97% no. New Zealand, they have one massacre.
Those down by lawmakers so that the manufacturer companies can keep selling them. No one, the people who get affected.
3 more minutes, so we'll take a look at the solution and then move on.
You don't check anything out, you go online. Well, my thing is actually like the business show and that commercial for the animations. If you're a person that believes you can't have this kind of mentality where there will be a moment where something happens and the reaction is so overwhelming that people will say, why do we even need this? It just takes it away. I'm surprised that no one's gone after the gun.
Outside of that,
Those issues don't really affect, they're important, but they're not like assault. Yeah. Like most countries don't have a second amendment. That's why they can change laws. I'm always in favor of the right to have. They're not limitless. If you don't have, like, if people don't want vaccines, like, great, you don't have to take a vaccine, but don't go into like public spaces. Like, yeah, that's great. If you don't have a right to use public services like schools, if you're not willing to protect everyone else, you know that like in Oregon, the big measles out there. Like, it's just like this. This is exist. I'm sorry. And as long as like those people have well, your rights end the moment that you start. But the thing is, there are limits to all things. But the NRA has such a grasp on Congress. This Congress is such it's like super you can imagine. Most of those politicians, tools, they're not real people. They're like Nancy Pelosi made $160 million after she became speaker. Right? Now I'm not going to be and Nancy Pelosi is as far away from the as possible. And to respect that, she made that money by passing laws and then going to the stock market and betting in the companies that she used regularly.
It's all building on top of each other. Okay, so let's take a look at the solution. So for chirps, you have a config folder that still has your MySQL database connection details. You're requiring the MySQL library, creating the connection, establishing the connection, and then exporting it for use elsewhere. You have a public folder that has all of your assets for your front end. That would be your CSS, your front end JavaScript, and your index.html. If you take a look at the JavaScript, that will be all of your jQuery GET requests. So that would be getting all the data at this URL endpoint. And then you have a submit function that executes a submit element that would create a post request to your server. Once again, that gets executed when the submit button gets clicked. Then all of this is tied together on the back end with the routes folder, where you have your API routes.js. And what you have over here is definitions for the individual routes. That's your server saying, I'm allowing you to execute a GET request on this specific server at this URL slash API all. And when I get a request at this URL, then I'm going to execute this query, select everything from chirps, connection.query. That's going to execute this string into the database, and then I'm going to return a JSON result. Same thing with chirp. I'm going to register a post request on this URL, API new. It's going to get the chirp data from the request body, and it's going to insert that body information into the chirps table, including an author, a body, and a created at value. Those values, as we can see, are going to be individual names in the request body. It's going to be the author, it's going to be the body of the body, and then a created at element. The first two are pretty simple. These are just going to be basic strings that we're typing into the input box. That would be, the name, the author of the chirp, and then the message that they want to chirp. The new thing over here would be the created at. If you guys notice inside the schema, there's a third column called created at, and it's a date time. This date time is going to be a date value that it gets from the front end. And the way we're able to create this date value is by using an old JavaScript function library that we've used in the past called moments. You guys remember that, right? The moments library for times. That's what we're going to pass back in the request body. So when you take a look at that index.html, where we have a script to inject moments into our website. That's how we have access to the moment functions. And when you look at the chirps.js, we don't need it in the get, because the get is just getting all that information from the database. Once it gets that database information, don't forget it's a JSON. We're not rendering this like we typically do when the website loads. So if you look in the routes.js for this solution, we're just returning the JSON result. Once we get that JSON result, we're going to iterate through it with a for loop, and then we're going to create all the different rows and add the styling and stuff that we saw over here. So that's the for loop that creates this section. And then at the same time, in this for loop, it has a time at this time on Saturday. It looks like we are actually using moments. Moment is being executed over here, where it grabs that created at element from the database, formats it, and then prints it on the screen. But the more important part is when we're submitting it to that database. For the created at element, we're using moments, open and close parentheses, dot format into this specific syntax. Is using this specific syntax because MySQL can be a little strict on the type of date time elements it accepts. So for simplicity's sake, use this datetime format when you are creating elements in the MySQL database that require a datetime. So once again, it's going to grab the author and the chirp box elements from their individual HTML IDs. When I do a inspect over here, you'll see it has an ID author. You're using jQuery to grab that information from the author, getting the value, and then we're trimming it, appending that into a chirp object, which we are then posting to that API new endpoint, posting the entire body. And then when we get a success from that code, then we're just going to append it to the chirp area. Chirp.prepend. Prepend, not an append. An append will tack it on to the end. A prepend tacks it on to the top. And that's pretty much it. So this shouldn't be new. And if you guys were still getting lost on the interactions on how this all ties together when you're looking at the solutions, definitely start jotting down some questions now, because we're going to look at a way to simplify this, but it is still important that you understand how all these pieces work. Question.
Why is it that we haven't used handlebars?
I'm sorry. What? Could you guys quiet down real quick? What did you say?
Why haven't we used handlebars?
Oh, just for simplicity's sake.
Is there a way we could have done this using handlebars?
Yeah, so you know where in the JavaScript we're iterating through the result in the database and creating these individual elements. We could have just done this in handlebars. We could have used that each special syntax, rendered it on the index, and then iterated through the object. It would have been a lot easier. Yeah, this is also just kind of like a way to reinforce the tools in your toolbox. You guys now have access to handlebars. You've learned about handlebars. You realize the speed and simplicity it provides to your code base. You no longer have to create individual divs and classes on the back end. You could do it all on the front end, but using the server to help facilitate that. Questions on this solution before we move on to Sequelize? Okay, so our next topic would be Sequelize. We're going to do this exact same exercise, except we're no longer going to create an ORM in the way we created it over here. Let me try and find that one more time. We won't be executing raw SQL statements in this next exercise. We're going to use a library called Sequelize to help simplify things in I guess, a easier to read or more user-friendly fashion for devs. But the description I'm going to give you, so let me slack out this URL. Sequelize is exactly the same as the ORM that we've been creating manually over these past couple of classes. It's a helper library that has functions like we saw in the cat exercise, the .all, the .create, the .update. It has helper functions like that so that you don't need to write the SQL statements yourself. It will write the SQL for you. But that's all the information I'm going to give you. For this next exercise, you guys need to get into the habit of being able to hear about new libraries, understand the general gist of what they're used for, and then finding that information out yourself. Being able to read these technical documents, diving into them, using Google to find the answers to your questions, this is very important to a developer. This happens every day. Especially these days, technology moves very quickly. New libraries come in and out of fashion. Who knows? Maybe next year SQLize will never be a thing and it'll be a brand new library. You'll need to always be learning how to find the information that you need and being able to get up to speed quickly. So the point of this next exercise, which will be number 2, SQLize questions. There's a couple of questions over here that we're going to go through. And you guys can do this in partners. You're going to take 15 minutes to find the answers to these questions. And some is going to start off simple and is going to get more complicated. First of all, what is Sequelize? What advantages does it offer? And then we're going to dive into how do I install this into my Node.js project? What is a Sequelize model and how will it play a role? You'll need to make sure you understand that model definition in MVC. Don't forget, a model is all about the database interactions. Views for template, controller handles is kind of like the glue between those two. And then when you have a test table that looks like so, how would I use Sequelize to interact with this table? These are the type of questions we want to figure out. So partner up, pull Google out. You have the main documentation page over here for you to iterate through, but sometimes your answer might be found in the Stack Overflow, which might be quicker. Spend 15 minutes trying to get the answers to these questions, and we'll go through them as a class.
like that's my biggest fear, like in this class is over, will be elements of like we assume so much now. Like you can that's why this class is good. That's what that is that's the because I'm here so what the user friendly. They soon I think they soon all this stuff.
If you're having difficulty trying to find the answer to a question, ask your classmates because it's also important to understand the type of queries that you want to use in Google. So getting an idea on how they're finding the answers to their questions will give you better insight on how you should formulate your Google query so you can get to the answer that you want quicker. 5 more minutes, and then we'll take a look at the answers. Yeah, I guess that's a simple way to say it, yeah. It's all about database interactions. Makes it easier to handle those interactions.
And then when it goes into like specifics of how it does it, like every other word, I don't like that.
All right, so let's take a look at some of the answers. Let's start with some of the simple ones at the top. What is sequelize? Who wants to take a stab at that before I volunteer somebody? Someone want to offer it up? All right, how about you? Right behind you. Yes. What is sequelize?
Got lucky.
This one should be pretty straightforward. We're just pretty much just Googling sequelize. It should get you an answer. So what is sequelize?
It's like it's ORM,
Correct. And what is an ORM?
object relational.
what does it do?
It communicate with the database.
Yes, it communicates. It helps you communicate with your database, and the idea is that hopefully it makes that communication easier. Um, so when we answered what is it, what advantages does it offer, we just answered that. It makes our interactions with our database easier. At least that's the expectation. So how do I install it? It's a node library. How do you install a node library? What's up? Yeah, so what would that look like? Yeah, npm install Sequelize. That's it. So then, what is a Sequelize model? I don't know how far we got in this one, so someone want to volunteer me what?
The table.
Yes, it represents the table. And what aspects of that table?
Columns. No.
Yep, the columns and the type of columns that they are. So whether it's a string, whether it's a blob object or a integer, things like that, we're defining our table because that's how you enable your ORM to work for you. It needs to know what table is it working on. So if I have a table with 2 columns and they're both strings, I can now know that when I return results, Sequelize is going to validate them and confirm that they are strings. So now let's get into the more complicated questions. Let's say I have a table that looks like so, and it has 4 columns: country, phone code, capital, and independence year. How would I model that in Sequelize? So let's dive right into the answers. And the JavaScript looks like so. First, we'll start with the table definition. You're going to have a Sequelize object, which relates to the library that we just installed. We would require it. And then the definition function for Sequelize is defined. That's how we're telling Sequelize, this is the table I want you to interact with, and these are the elements of the table that you need to be aware of. So you provided a table name, and this gets assigned to a variable, which would be the table name for simplicity's sake, but doesn't have to be that case. And then each individual column, you would say in this JSON, in this JavaScript object, the key would be the column name, country, and then the value would be an object type. And that we would use Sequelize string to define that this is a string type. Same thing for phone code. We would have a phone code key. The type would be a Sequelize integer. These are all numbers. The capital would be a string as well. And the independence year would be another integer that would relate to the values in this database here. Now there's some options that you can have with Sequelize that we'll talk about a little bit. That's in the solution. Freeze table name true. It's just a way of Sequelize saying that the table name that we're passing in over here is exactly the same as the table name in the database, and there's no like plurals or any of that stuff. That it's the capitalization is exactly the same. The next part of this solution is this sync function, and I don't know if you got a chance to take a look at this, but this is pretty important because it can handle some functionality for you. When you finally get that table object from the Sequelize define, now you can execute commands on your database because you've already told it what table we're working with. So when you call table sync and you pass in this option parameter force true, if the table exists, it'll drop it and then recreate it. If it doesn't already exist, it'll create it for you. So sync is just going to recreate your database and delete everything that was in there. So be aware of that. That when you call sync, there's a possibility that you might lose data if you already had data there already. So then the table is created, and then when the table is created, when you call that sync in the callback function, then there's a function that we can now use to create some initial data. And so remember how we were manually inserting that seed information with insert statements? We're now going to use the table name and the create function. This create function is going to be your ORM insert SQL statement. It's going to create this data from a JavaScript object, and you're going to pass in the keys which pertain to the columns. So when we're creating a brand new table element for this table, we need to provide a country, a phone code, a capital, and an independence year. So the object we pass into the create function will be exactly that: country, phone code, capital, independence year, and that's it. It handles the insert into this table with these values portion for you. Question?
So the syntax starting at line 37, that doesn't change.
Line
whether
37?
you're using MySQL, Postgres, MariaDB, that will remain the same, right?
That's a great question. So you need to make sure that your ORM supports those different database types. Some ORMs support some don't.
Yeah, so assuming it's supported.
Assuming it supports all those different database types, then that's all you have to do. They've built the logic on the back end to massage that SQL statement into something that makes sense. Because even though all these databases, that's a good pivot point. Even though all those databases, you can use SQL to access data, create data, they have their own special flavors sometimes for certain scenarios of SQL. So Oracle database, certain SQL statements can work in an Oracle database that don't work on a MySQL database. So ORMs help make your life a little easier, so you don't have to worry about all those different nuances. So yeah, so that's what handles that. You would use the sync function to create your database, and you can force it so it can drop it if it exists and then recreate it. You would use the create function to create that seed information for when your database starts. And then we're using the define function which is really the most important function. This is what's telling your ORM, this is the table I want you to interact with. These are the columns that are defined. Help me put data in it and play around with it. Then that final question, which is, let's see, how would I query for all the records where independence year is less than 50 years ago? We take a look at that answer. Let's scroll down. You would use the find all function for the ORM. So table name dot find all. Then you pass in the different options. For here, for find all, we know that it accepts a where clause. We know it accepts a where clause because that's defined somewhere in the documentation. We're not just pulling this out of our head. So if we look in the documentation somewhere, there should be a reference. Oh, and here we go. For SQLize, you can see it supports MySQL, MariaDB, SQLite, Postgres, and MSS SQL. So we know we're good for those databases and handling those different types of interactions. But if you want to understand how do we query data in our databases, we go to the querying section in this documentation and just look at like the different examples that they provide. We know we want to use a where, so we look at how they're using where. So for a table post dot find all, we'd say where author ID equals 2. Find all where author ID is 12 and the status is active. And you can see that this is the type of SQL is actually printing on the back end. From a usability perspective for a developer who might not be very familiar with SQL, this is a lot easier to handle than building out the SQL statement myself, where I'm saying select everything from the post table where author ID is equal to that and status is equal to that. You guys see how this works? These are just helper functions that are still creating SQL on the back end. Don't ever get that confused because this isn't doing anything magical. It's just abstracting away the complexity sometimes of building SQL yourself, and they will build the SQL for you. Keep in mind that ORM to databases is like the bootstrap to CSS. Once you start doing things their way, it can be sometimes hard to customize. So when you want to do something that your ORM doesn't have defined or your ORM hasn't created a helper function for, you'll have to build that raw SQL yourself. So just be aware of that. Sometimes ORMs are great for particular scenarios, and sometimes if like you're building a very performance-focused application, an ORM might not necessarily be the best thing because raw SQL will always trump generically built SQL from the backend. Because sometimes, like in Ruby and Rails, sometimes the ORMs can be very inefficient and will have very efficient select queries for when you want to do something very, very small. So nothing you probably have to worry about for this class, but just something to be aware for future development, where an ORM just isn't cutting it, and raw SQL will always trump an ORM.
So we can use SQLize not just for retrieving data or creating, but also to delete,
Correct.
update.
And we know that because we could just take a look at their documentation. When you want to understand what is possible, just look at the docs. We know that we can do querying. We know that we can, let's try and find an update and a delete. So we have finds and min, max. Let's look at instances. Creating persistent instances. Here we go. So we can use a table name .create, and then I'm sure there's an update. There we go. There's a destroy. So we can destroy things. That would be a deleting thing. It's just reading the docs and understanding what's possible. So before we get on break, let's take a look at some more of these other questions. How would we query a table and order it by descending independence years, and also limit those results to just two of the records, skipping the first two? This is just a reiteration of the find all, but we're using more complex options for our specific use case. So we're doing a table name .find all. We're going to skip the first two results. We're going to limit the results to just two elements, and we're going to order them in a descending fashion by the independence year column. So you can see we can now begin to build complicated SQL. But this would look very complex if you saw just the raw SQL itself. This kind of helps from a usability perspective. This is much easier to read than some of the SQL statements we saw earlier where we had left joins and right joins and all that extra stuff. So yeah, so any questions on some of the solutions that you've seen so far? Because we're going to put this into practice. I'm going to walk through the Chirpy exercise and show you how we're going to rebuild the Chirpy MySQL solution, but using SQLize. And then once I show you that solution and you get a chance to play around with it, we're going to actually get you guys to practice with SQL in the Star Wars exercise. So what would you rather do? Have me walk through the Chirpy SQLize now, or do that after a break? After the break, raise your hands. Or before the break, raise your hands. All right, we'll do it after the break. Cool. So yeah, let's go on break for 30 minutes. So we'll be back at 12:25, and then we'll continue.
Sure, we'll let you join us.
Don't be a party pooper. Hey, Don, what's up?
So,
Sure.
like, I know we learn a lot of libraries in this class.
Yes.
I wanted to see, like, just from your perspective,
Yes.
how often they're used at enterprise level.
All the time.
All the time. Okay.
Yes, especially, really it's just for speed.
Okay.
And also these days, developers, because of these helper libraries, don't really understand SQL like we used to.
Okay.
And the same thing you can say about CSS as well. With the invention of Bootstrap, I'm
Why
not a
do
front-end
it again?
developer,
Yeah.
but I can easily build websites and not have to understand the CSS behind it. So for the most part, these type of things are done, but that's where you can run into issues. Because now you have developers relying on ORMs, and when they need to build something complicated, building that raw SQL now can become difficult, or that ORM is doing things very inefficiently.
Okay.
Like I remember one time I was working on a Ruby on Rails project, and I was just trying to get a query for a single object in a single table, and it created like 16 different select requests just to get one object. When I could have just built that raw SQL myself and done it in
And
one,
just call it.
one statement.
Do the one statement.
Yeah.
Yeah.
So you can run into traps like that, but it's used everywhere.
Okay.
Yeah.
Okay. Cool. Like, I guess are there other equivalents of this? Because I already know like the position that I'm going to be working at, so
Okay.
I'm kind of trying to translate it, but still like always learn more
Yeah.
stuff. But like I know we work with like Microsoft Stack, like C#, SQL.
Okay.
I've looked at the code, and I know what the equivalent of this looks like. It's kind of
Yes.
crazy because there's like it looks like a table, but there's like
Yeah.
a code backend to
Yeah.
it.
Yeah.
So like you could kind of drag and drop and play around. So it's
Oh, that's
really user
interesting.
friendly for me
Okay.
to understand like we have maybe 50 or 100 tables, right? And each one of them, you know, is going to have one of these qualities. I guess.
They probably call them DOA objects, data
Okay.
access objects.
Okay.
I know that's what they call them in .NET, and those act the same as a model in ORM. Like you said, it defines the different elements in the table and gives you helper functions to play around with it.
Okay. Yeah. Okay. Okay. Cool. Yes. Yeah, because I'm trying to like understand why, because it's like an app that's already built, right?
Yes.
So you have to like step in and be like, okay, like what the hell's going on, and just always like trying to, yeah. So that's sort of the process personally I'm going through, is like trying to translate like
Understanding why they made certain decisions for certain
why
things.
they did that, yeah. And
Okay.
like
That's just, they probably built that layer to help new developers coming in ramp
Yeah.
up quicker.
yeah,
Yeah.
that's cool.
That's usually one of the main reasons for an ORM.
Yeah,
Because I can get you in without you needing to understand the SQL behind playing around with the objects, and now you can build functionality reusing the functions I've given.
yeah,
Yeah.
that's cool.
Cool.
Yeah, thanks.
Yeah, no problem.
Try to should get a project where you put all that stuff into one project. And then recycle it and then sell it for like $50. I'm sure someone will want it in China or something. Repurpose it. Just put out, try to create it if you wanted to. Yeah. But no, you might need a
One step at a time. I guess I gotta get back into the thing. Step back.
I still do the French to home, friend, and then, oh, I see. Oh, you should, I think we should, you'll be fine.
Yeah.
You're picking it up at the Apple store, right? You know the Apple store?
All that stuff making sense.
I mean, better get used to the
The syntax and all that. Sure. Yeah, that's
I use
always tough.
SQL at work. So
Oh.
SQL is easier actually.
Oh, okay. I mean, that's probably the better way to learn things.
Yeah.
Because once you get good at SQL, then sometimes you can appreciate the simplicity of things like SQL.
Yeah, I just need to learn the syntax now.
Sure. yeah. So